question, 1,172 dinner plate stacks. You have an infinite number of stacks arranged in a row and numbered left to right from 0. Each of the stacks has the same maximum capacity. So the question is saying the capacity is given to us. Let's say the capacity given to us is 2. It says you have an infinite number of stacks arranged in a row and number from 0 to the end. So what it's saying, it says, like, let's say we have a stack and the capacity is 2. So we have one stack, we can have infinite number of stacks. So let's say, and I'm leaving it empty, I just put like these dashes so it shows the capacity is 2 and we need to fill that, right? And so on. And it says the stack, it's a number from 0 to infinite, right? So it's going to be 2 and it's going to be 3 and we can have infinite number of stacks. Let's put them all in one big stack. So we have smaller stacks that can be infinite, and the number of items that we can put in each stack is equal to the capacity that we have here, right? So let's see what the question is asking us to do. The question is saying we can push, pop, and pop at a stack from these stacks, and we need to write down and develop these functions. So for the push, what we can do, it says pushes the given integer, the val that is given here to us, into the leftmost stack with the size less than the capacity. So when a value is given to us, we are going to push it here, and we start from the leftmost stack with available spot. So let's say we want to push, 1, 2, 3, 4, 5, like 6, right? The way that it will happen, I'm going to copy and paste this so we will keep that there. So the way it will happen, we are going to have 1 here, then we are going to have 2 here, and then we are going to have 3 here. It pushes from the leftmost stack to the right side, right? So 4 is going to be here, and then we are going to have 5 here, and then we are going to have 6 here, and so on, right? And let's say now we are going to pop an item from the stack. The thing it says here for pop, it says return the value at the top of the rightmost non-empty stack and remove it from the stack. And if the stack is empty, we are going to return -1. So let's say now this is the stack that we have, and we are going to pop. If we pop from this stack, we are going to pop the most right one, which is 6, and then we are going to remove it from the stack. And then if we pop again, let's say we pop again, and what will happen, it's gonna pop 5 and it's gonna remove it from here. So this is how it works for the pop. And if the stack is empty, if we pop 4, 3, 2, 1, then a stack is going to be empty. And if it is empty, we are going to return -1. Now let's see what pop at a stack does. The pop at a stack, it says an index is given to us. It says return the value at the top of the stack with the given index. So if the index is 0, it says it will return the value at top of the stack with the given index. So it goes to the stack, it finds the 0, 1, which is this, and return the value that we have at the top, which is going to be 2 here, right? So it's going to return 2, and we are going to have an empty space here. So far everything seems like simple. But what we need to know, it says push the given integer into the leftmost stack with the size less than capacity. If pop at stack at index 0, then I'm going to have an empty spot available here. So the question is, when I push, for example, 7, I want to push 7, what will happen? Is it going to be added here, or is it going to be added here? That's right. it is going to be added here. If I have 7, it's gonna be pushed here, right? It's gonna be added to the stack, the leftmost stack with an available spot. And if I push 8 now here, then it's going to be added here. So this is what we need to handle for this question. And for handling this, we need to keep track of like available spots, the empty spots that we have in the left side of the stack. What we're going to do, we are going to first, we need to self.capacity is going to be equal to capacity. And then I'm going to have a stack. I'm going to call it stacks because it's like made of like infinite number of stacks, right? It can be made of infinite number of stacks. So it's going to be the bigger one, and I'm going to have an empty stack in here. And then I'm going to use heap. The reason that I'm using heap is because heap has this property that every single time that I pop something from the heap, it's going to return the minimum. And like what I mean by that, so when I pop at the stack at index 0, I'm going to remove this. So I'm going to have an empty spot in here, 0. And let's say, let's go through this example. Let's say I'm going to, this is the example. I'm going to write it down here so you can understand. Let's say this is the example that we have, and I'm going to pop at index 0 the top value. So it's going to return 7, right? And then I'm going to pop another value as well at index, let's say 1. So it's going to return, say it, 4. That's right. So it's going to return 4. Now I'm going to push, let's say 11. What will happen? Is it going to be pushed here, or is it going to be pushed here, or is it going to be pushed here? The question is asking us to push it here. So 11 should be pushed here. But how do we know which spots are available? First thing is, if we can have a heap here, and if we put, let's say, if we have a heap here, and we put 0 and 1 in it, and then we pop the minimum value from it, it's going to be index 0. Then when we push it, it goes and check the index 0. If there is available spot, it's going to put it here. So that's why we need heap here. And also we need to keep track of indexes as well. So let's see how it works. First thing is, as I explained about the heap, we need to check if heap is not empty. And heap, if it's not empty, what we are going to do, we get the index of that stack that we need to put push the value in it. So I'm going to say heap q dot heap pop, and I'm going to give the self dot heap to it. So it's going to give us the minimum index, and then I'll go to the stacks. I'll go to that index, and I'm going to append that value. And also I need to update the self.idx to the maximum of self.idx and idx, right? And now let's pop. When we are going to pop, we need to check sorry, I forgot to do the else here. And else, if the heap is empty. And if the heap is empty, what we need to do is we need to check if the length of the self.stacks, right? If the length of self.stacks at that index that we are going to push in is equal to the self.capacity. So it means that the stack is full and we cannot put any more item in it. So what we are going to do, we are going to self.stack plus equal 1, and then I'm going to add an empty stacks here, because it's like equal to the capacity, so it's full, so we need to add another one. And then what I'm going to do, I'm going to say self.stacks at self dot index, it is going to be dot append the value that we have, right? There we go. And now let's do the pop. For the pop, we need to check the index. That's what index the IDX is pointing at. While self.idx is bigger or equal to 0, which we are going to make sure if it is within range, and the length of the self.stacks at self.idx, if it is equal to 0, which means that the stack is empty, and we don't want to pop something from an empty stack. It's something like this. We don't want to pop this, right? So what we need to do, we need to self.idx minus equal 1, right? We need to go one step to the left, and then we are going to say self.idx, if it is bigger than or equal to 0, which is within range, we are going to return self.stacks at that index dot pop, and otherwise we are going to return -1 because that the stack is empty, right? And now let's deal with this, the pop at the stack. I'm going to run examples, so if there is a confusion here, you can understand it, like we can fix it later. So if the index that is given to us, this index is given to us, we need to check that. If it is less than that, we need to check if it is within range or not. Length of the stacks, and also if the length of that self dot stacks at that index is bigger than 0, sorry, my bad, we need to add this to the heap. So we are going to say heap q dot heap. We are going to add it to the heap because we are going to pop it after self, so we need to store it somewhere before popping it. So heap dot index, and then what I'm going to do, I'm going to return self dot stacks at the index dot pop, and else we are going to return -1. So let me remove this. So let's make sure that we don't have any typo. This is something very important that you need to check. Sometimes typos cause problem. So I will run it and see. There you go. We have a typo here. So we have a typo here that we need to fix. So let's go through this again. So we have a stack, we have index. We forgot to assign a value to it. So that was a mistake. And also it says we have a problem here for the push. I forgot to put the self dot. These are the most important thing that you need to check after you are done with your code. And there you go. So let's go through the code one more time, so very quickly. So the capacity is given to us. We are going to have a stack of stacks, and we are going to keep the value of the in the index of the stacks that we have popped from here, and also the index. This is the pointer that we are going to use. This is the push function that we are going to check in our heap. If there is an empty spot available in one of the leftmost stack, we are going to put it there, and otherwise we are going to add it at the end of the stack. And for the pop, we need to check if it is within range, and at that index the length is not empty, and if it is empty we need to move to the left. And what we are going to do after the idx is at the right spot, we are going to pop it, and if it is empty, we are going to return -1. And for this one, what we are going to do is asking us to pop an item from stack at index, like whatever it's given here to us. We need to check it is within range, and we need to check if that stack at that index is not empty. And if it is not empty, we are going to store it somewhere in the heap so we can use it later for push, and then we are going to pop it. And if that stack, that individual stack is empty, we are going to return -1.